In this learning cycle, we're going to play with control structures. Control structures in R are special functions. Like operators, which are also functions, they have a different format than most functions. The purpose of a control structure is to allow you to control which program elements are executed based on a decision with a logic outcome. There are 5 control structures that we're going to look at. These are the 5 main control structures in R. And we're going to begin with the if and else control. Now in life, we might ask, what will I do on Saturday night? If the symphony is performing, I will go to the symphony. Else, I will go to a movie. In R, what is the student outcome on the test? If the score is at least 60, the student passed. Else, the student failed. So let's actually see this in operation. Let's set up the student outcome on a test. Let's set it up to be 72. You can see here in the environment, the student score is 72. Now this is the structure of the if and else. So we start with the keyword if, and then we have a logical statement. The logical statement is a statement that's going to result in a true or a false. So note that I'm using the Boolean operator greater than or equal to. So this is going to look at the student's score. If the student's score is greater than or equal to 60, it's going to then do what's in curly brackets. So here's the opening curly bracket on line 29, and on line 31, right at the beginning, you see the close curly bracket. In between those curly brackets, we have student outcome, a new object, will be assigned the value of pass in quotes. So this isn't a logical, this is a character string because it's in quotes. So if the student's score we're going to look at is greater than or equal to 60, student outcome is going to be pass. Now on line 31, we also have an else statement. Else, do what's between the next set of curly brackets, which start here right after the else statement and end on line 33. The student outcome will be set to fail. So we have set the student score to 72, so we know what's going to happen. The student's score is greater than or equal to 60, so the student outcome should be pass. Let's run this. So the whole statement ran at once, all of this. Notice the cursor went all the way down to the next statement on line 35. And that whole statement all at once gave us student outcome of pass. Let's do it again. This time we'll set the student score to 53. So you can see in the environment, we now have 53. Let's run the next if-else, which is the exact same if-else, but notice the different value now. Student outcome has been set to a character vector that says fail. The else statement is actually optional. We could have done the above like this. Let's go back and reset the student score to 72. But now, before I even get to the if statement, let me make the default student outcome fail. That doesn't sound very good, but there it is. The default is fail. But if the student earns enough points to get over 60 or at 60, then this if statement says the student outcome will be pass. Notice I didn't even need curly brackets. So now we have a pass. Let's try it again with 53. Again, I'll set the default as fail. If student score is greater than equal to 60, student outcome is pass. Notice it did not change it from fail to pass because the score was below 60. Here's an alternative way that R allows us to write these statements. I can actually set the student outcome to be assigned a value based upon the if-else. So if the student's score is greater than or equal to 60, I can assign it a pass, else a fail. So let's do this again. And so what is the student score right now? It's 53. So here we go. And we get a fail. If I change that student's score, let me do that just so we can see the other way. And let's set it back to 72. And now let's run that again. And now you can see the student outcome has been set to pass. So you can actually use an assignment operator in order to assign one or the other of these two outcomes. Now, the other thing to note is that we can put as many statements as we want between the curly brackets, and that's going to become hugely important in the future. So here, I'm going to set the student score to 72, and now I'm going to have another object that I call numPass, and that is going to be set to 0. And now let's look at what I'm doing here before we actually do it. If the student's score is greater than or equal to 60, I'm going to do a few things. I'm going to set the student outcome to pass, and the brackets have not ended yet. The curly brackets have not closed, so I can keep writing statements. I'm going to say the number of pass is now what it used to be plus 1. Well, right now it's 0, so the first time we go through this, it will turn it into 1. Else, if the score is less than 60, then we'll skip all this and we'll come right down here and set it to fail and won't touch the number of pass, so it will remain whatever it's at. So let's go ahead and run this. And you see that we now have a student outcome of pass, and we have the number of pass now equal to 1. Now, what if we used a vector of length greater than 1? Instead of a single student score, let's suppose I have a whole vector of scores. So now I've created student score to be 10 scores. Let's try what we've done before, that if the student's score is greater than or equal to 60, we'll get a pass, else we'll get a fail. When we run this, notice what happens. Student outcome did not become a vector, it was only 1. Well, what happened? The warning message tells us what happened. Our condition had length greater than 1, it had 10, but only the first element will be used. So it only looked at that 72, and that's why it set it to pass. That's not what we wanted. I wanted it to do it for all of these. So the thing to keep in mind about the if and the else is it only works on scalars. It only is going to deal with this first number if it gets more than a single number. Well, that doesn't sound very convenient. What about vectorizing? Well, fortunately, instead of using the if and else, we can use if else. If else is a single function, and it's meant to work on vectors. Now we'll look at student score greater than or equal to 60, and if it's greater than or equal to 60, we'll give it pass. Otherwise, we'll give it fail. So let's try it. That's more like it. Look at what we have here. So we have a student score vector, and now we have the outcomes. The 72 resulted in a pass, the 53 resulted in a fail, the 80 resulted in a pass, and so forth. We often like to have our scores stored with the results, so let's go ahead and create a new object called student test data, in which we bind together the student score and the student outcome. And you know from column binding that if we look at the class of student test data, that we have a matrix. We can view that matrix with the view command. Let me type it in. And here it is. So we now have a little spreadsheet in which we have each score, and next to it we have the outcome of whether the student passed or failed. Let's use the logical operator and find out how many students passed. 8 of the students passed. Remember that all the values here that are true will give us a 1, and if they're false, they'll give us a 0. So by checking with this Boolean equality operator, the double equal sign, I was able to check student outcome equal to pass to get a row of, or a vector of trues and falses, and the trues were all coerced to 1, and so the sum was 8.